Welcome to a deep dive into one of the most persistent and frustrating problems in production: React Native apps, memory leaks, and app freezes. We're going beyond the basics today. If you've shipped a React Native app, you know the pain. Users report freezes, crashes, and sluggishness, often leading to ANR's application not responding errors. But what's truly happening under the hood? In simple terms, a memory leak is when memory is allocated but never released, even though the application no longer needs it. In React Native, this happens within the JavaScript context. It means you have objects, closures, or references that the garbage collector mistakenly thinks are still reachable or in use. They remain indefinitely in the JavaScript engine's memory space. As this unreleased memory accumulates, the heap size balloons. This forces the garbage collector to work harder and more often, consuming CPU cycles, leading directly to reduced performance in janky UI. Now, let's identify the usual suspects, the most common architectural missteps that result in significant memory leaks in React Native applications. The most frequent source of leaks are timers like set interval and global event listeners. If they aren't properly cleared when a component unmounts, they hold a reference to that component's scope forever. Mismanaging component lifecycles, especially with complex state objects or references held by native modules, is another common culprit. When a JavaScript object is referenced by a native object that isn't released, the leak bridges the native layer. Memory leaks lead to performance degradation, but app freezes and ANRs are often tied to another key concept: the difference between the JavaScript thread and the UI thread. The JS thread executes your React code, while the UI thread handles rendering and user input. When the JS thread is blocked with synchronous heavy work, the bridge is clogged, and the UI thread starves, resulting in a visible freeze. Jank is usually a series of small, missed frames. An application not responding, or ANR, is a catastrophic, sustained freeze caused by a single piece of code blocking the main thread for too long. Identifying which thread is the source is critical for debugging. Have you ever noticed your app runs perfectly fine during development, but as soon as you push it to a release environment, the performance cliff hits? Let's explore why. The debug environment provides helpful, but costly, developer tools. This often masks true performance issues, making the app feel smoother than it actually is when it hits production. In release mode, the JavaScript bundle is minified and optimized. Crucially, the garbage collector behavior and JavaScript engine, like Hermes, are running with full production flags, which can expose leaks or sync bottlenecks that debug mode obscured. You don't always need a profiling tool open to catch a potential leak. Developing a, quote, profiler mindset is an essential skill for any senior engineer. The core of the profiler mindset is extreme lifecycle awareness. Always ask, when does this component mount? When does it unmount? And what references is it holding onto outside of its own scope? Look for memory sinks, places where you pass a local component function to a global object, like a navigation service or a global state manager. These global references are often the root of unreleased memory. Finally, before deploying your React Native app, run through this mental checklist to ensure you've covered the most critical memory safety aspects.